Hey everyone, let's solve problem 2011 of LeetCode in APL. So the problem statement says that there's a programming language with only 4 operations and one variable x. And the 4 operations are the increments and decrements that we see here, the plus plus x, x plus plus, minus minus x, and x minus minus. And the value of x starts at 0. Now we're going to get an array of strings that represent some operations, and then we need to return the final value of x after performing all the operations. Now I thought this problem was new to me, but I think I've seen a code report video solving this. I'm not entirely sure. So yeah, I'll link in the description. I'll link to whatever video I'm thinking about, because I don't really remember which one I'm talking about. But the way in which we can solve this is we just need to count pluses and minuses. And well, there's plenty of different ways in which we can do this. So let me define some of these strings. So the input is going to be minus minus x, x plus plus, and let's do plus plus x. So this is the input, and now we need to work with this. So there's, like I said, plenty of different things you can do. The first thing we need to do, or the first thing we can do, is distinguish between the pluses and the minuses. And we can do that by always looking at the middle character of the operation, because x can be in the beginning or at the end, or in the end. But in the middle, you always have the operand that you care about. So, for example, we can mix the inputs, and then we can extract the first column. So we can do something like this. All of the rows column 1, or if you prefer, we can do something like we can use the index function after transposing the mix. And now we need to how can we do this? Well, we can just count the pluses. So where is plus? Or let's count the number of times plus is equal to this. Right? And now these are the increments, and the decrements are the minuses. And we don't need to count them explicitly because we know the length of the inputs. And so the final value will be this value right here. Let's call it the pluses. So what we want is going to be p, this is the number of times we increment, minus the length of the input minus p. So this is the number of decrements, and the number of increments minus the number of decrements gives us the final value. Now we can simplify this a little bit, and this is going to be from a mathematical point of view. So p minus something minus p is the same as doing 2 times p minus this. So we can do something like 2 times p minus this. Now what we need to do is check our answer with some more test cases. So let's see, just a bunch of pluses. Right, so I need to redefine this. So let's make it so that the increments can be counted with a function. And so p is the increments we get from plus plus x plus plus x, x plus plus. So we've got p, we've got the input here, and the final expression was 2 times p minus the length of the input. So the final value is 2 times p of omega minus the length of omega. So v of input is 3, the v of the previous one, of the previous input, where is it? Let's check the v of this. So the final value here is 1, and we have one final test case here. Let's go with it. So x plus 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 x minus minus x, x minus minus, and we get 0, which is the correct value. So this was fairly easy because I had seen this problem already somewhere else. I'll leave it as a challenge for you. There are many different ways in which you can solve this. One such way could be, for example, by enlisting everything and now using indexing to pick just the signs. Sorry, this one. No, yeah, this one and this one. For example, so this is one alternative. You enlist and then you use indexing to pick the middle values instead of mixing things like I did. So I did this and then looked at the middle column. You can also, for example, flatten and use indexing. So as a challenge, I'll leave it up to you to solve this problem by following this strategy. Well, that's it for now. I'll see you soon. Bye.